What we're going to do now is called simple waves. Now it's a bit dangerous because anything in maths called simple usually isn't. So the most dangerous title of a maths book is Introduction to. So simple waves. It's best illustrated with an example, and then we'll talk a little bit about it, I think. So the idea is that there's basically a still region where all the characteristics come out of some still region. So we're going to do the dam bake problem first of all. So it's a classic problem that you have this, here's x and here's t. Here's x and here's h. So this is the initial height of the fluid. It's like that at t equals 0. So t equals 0 is still water where x is less than 0. And we're going to call this height here h0. Alright, so, and of course, the velocity at t equals 0, the u is equal to 0. There's no motion of this fluid, and we release it. There are experiments you can see. It's a classic problem to simulate numerically the dam break, and there's even experiments where people have tried to put a screen up here and they've used wax or something and they've heated it to instantaneously destroy it and try and trace out the pattern. Okay, so we've got these we've got the system of characteristics and the system of invariants. So let's have a look at the structure of these. Alright, so maybe the first thing to do is just to remind ourselves here that we've got this relationship between C and H. So C is the square root of GH. Okay, so we can work in terms of H or in terms of C. So we've got the system of characteristics, R plus or minus, this is the invariant, is U plus or minus 2C. Now, all of these characteristics start inside this region here. They all start from somewhere in here. We're not interested in here because there's no fluid. So all the characteristics start in this region here. So they must, this thing here is a constant, and it equals the value in the still region, because it can't change. So what that tells us is that this is equal to 2, what I'll call C0, which is 2 times square root of GH0, plus or minus, depending on whether you're on the plus 1 or the minus 1. So this quantity here, U plus 2C, so it's a bit tricky because it's the quantity U plus 2C is equal to 2 plus or minus 2C0. Okay, so everywhere U plus 2C must equal 2C0, and U minus 2C must equal minus 2C0. Okay, so what does that tell us? There's only one solution to this system of equations. Right? It's a linear system of equations, and you can solve it. And the only answer is that U must be equal to 0 and C must be equal to C0. But what that's saying is that the characteristics that start in this, when the two characteristics meet that start in the still region, they have we're in an region of undisturbed fluid. So this is undisturbed. Oh. Okay, so basically, if the characteristics that start in this region ever meet, then we're going to have this undisturbed fluid. And let's have a look at the equations of the characteristics. So the C plus is given by dx plus dt is equal to u plus c, which if we're in this region is equal to, so u is equal to 0, c is equal to c naught is equal to c naught. So it's a straight line with slope c naught. And dx minus dt is equal to u minus c is equal to minus c naught. Okay, so this is a bit sort of contradictory because we're just basically saying, it looks almost like we're just saying the solution is always going to be equal to 0 and constant, but I'm just going to draw you a picture of this so we can understand it. So I'm just going to try and make some space here to draw. Alright, what I'm going to do is I'm going to draw on the, don't do that, I'm going to draw on the page here, maybe with this green colour. Alright, so the minus characteristics, C minus, have constant slope and they come up from here. And this one here is given by, so now we're changing this to be the t-axis, not the x-axis. These are the C, just like we did with the car, these are the C minus characteristics. And this one here is given by x equals minus C naught t. Okay, so those are these are the minus characteristics. And then in purple are the plus characteristics, which have the opposite slope. Okay? And this one here, so what happens is this is the final characteristic, the minus characteristic that can leave this region. Right? So this forms a super important boundary. From here on, anything can happen. These are allowed to do whatever they want. So this is where the region fluid starts to become disturbed, and we've got to work out what happens. So now we get into some tricky little thing we have to decide. So we know that coming out of this equation here, these characteristics start to curve or do something silly. We'll see that in a second what they actually do. But we know on every single point here, we know from here that on all of these, we know that u plus 2c is equal to 2c naught. Okay? We don't know now, we don't have the other characteristic coming, but we know this equation is true. Alright, so I'm going to get a little bit metaphysical here. It's quite difficult to explain this, or maybe just you have to sort of go through this a couple of times. But what's happening is, up here, into this region here, so there's a line here, x equals minus c naught t. Inside of this region here, the characteristics come up, and the only solution that's allowed is u is 0 and c is c naught. So this fluid here is undisturbed. It's just resting, and then it starts to flow away. Now when these curves come out here, and we know that they carry u plus 2c is equal to 2c naught. So we know that everywhere in the entire fluid, u plus 2c is equal to 2c naught. I'm going to write that down here. So everywhere, u plus 2c is equal to 2c naught. This is why they're called simple waves. They have this property. This is the key property. So because these characteristics, anywhere in the fluid, one of the characteristics started in the undisturbed region, so it carries this information that u plus 2c is equal to 2c naught. So u can change and c can change, but they have to be equal. So now let's try and find this next characteristic. I'm trying to find a good colour for it. Maybe there's yellow here. So now we're going to have to try and work out what happens here to these minus characteristics. Now what do we know on this one? We know that on this characteristic u minus 2c is equal to a constant k, which we don't know. So this is from the C plus. From the C minus, we know that U minus 2C is equal to another constant, but that constant might depend on the line. Over here it's equal to 7, over here it's equal to 8. It might be changing. But if we have U minus 2C is equal to K, and we have U plus 2C is equal to 2C naught, we can solve and we get an answer for U and an answer for C. So on the C minus characteristics, we solve that equation, that 1 and 2, we solve them, 1 and 2, and we get U is equal to something and C is equal to something. So U and C are constant on the characteristic. So U and C are constant on C minus. So let's just go back with this to this picture here and try and understand it, okay? Because it is difficult to get. So we have the characteristics coming out, and on the purple characteristics, the plus ones, U plus 2C is always equal to 2C naught. So, and we assume they fill the space. So we know every single place in the fluid, U plus 2C equals 2C naught. Then we take these minus characteristics, and as long as they're this side of the slope, then we're in the still water region where U minus 2C is equal to minus 2C naught. But once we cross over into this region, we only know U minus 2C is a constant, which could be changing. But we know that if that's true, then U minus 2C is a constant. Then we combine with that and we get U and C are constants. So what that tells us is the C minus characteristics are straight lines. Okay, we're almost here and we're almost ready to solve. Alright, we're almost ready to finish here. So, the only way, so these characters, the minus characteristics start to bend over, and the only way that can happen is if they have to start at the origin. So they are straight lines which start at the origin. Okay, I'm going to write that down here. I'm going to grab another colour. I don't know how much these colours are helping us. So, the C minus, okay, they're straight lines from the origin. They're straight lines because they can't start anywhere else because there's no fluid here for them to come from. But they start from the origin. It's like an expansion fan fanning out here. Here's the next one coming down like that. So what do we know about those straight lines? We know that the x minus dt is equal to u minus c, which is u minus the square root of gh. Okay, and then we don't know what the height is here. The height, as they carry out these, as they come out here, they're carrying a different height. Well, we can solve that equation. So we get, since they start at the origin, we get u minus the square root of gh is equal to x over t. Okay, so I've gone on for ages. It's hard to know when to stop here. This is quite a brutal lecture. I've certainly run out of space as well. But we've got u minus gh equals x over t. That's one equation. And we also know that everywhere u plus 2c, which is 2 times the square root of gh, equals 2 times the square root of gh naught. And we can solve that. So that's equation 2, and that's equation 1. And we can solve those equations. Okay, that gives us the solution to the, imagine trying to solve that, you can solve that equation. I'm going to stop here and then start the next part. But you can solve that equation now and find out what h and what u and h are.